name's Deborah. I'm a Professor of Design for Circularity and Sustainability at London South Bank University. Nice to talk to you.
Thank you very much. So Let's Talk Tech is giving visibility to a notable woman in STEM who is integrating environmental sustainability to innovation in design and engineering. Professor Deborah Andrews is a professor in sustainable design and manufacture in the School of Engineering at London South Bank University. She supports the data center industry, an industry that emits the same amount of carbon as the airline industry. She supports this industry to transition to an environmentally sustainable model. Welcome, Professor. Please tell us about you and tell us about what you're doing.
Okay, so my background originally, I studied product design and industrial design as under and postgraduate student, and then started working and eventually ended up here at London South Bank and moved from quite conceptual design into more technical design and became increasingly interested in environmental issues. So over the years, my work has focused more and more on environmental factors and trying to identify ways to improve the environmental footprint of products, services, and systems. And in, 2010 or 12, I was introduced to the data center industry by Robert Tozer, who's a professor here as well, a visiting professor. And I first supervised a PhD program, which was building the first life cycle sustainability assessment of data centers. And what we wanted to do was to identify the real hotspots, the real problem areas, because the industry then and now, believe it or not, kind of 10, 12 years on, is still focusing on operational energy efficiency. And that is not enough. The data center industry has expanded exponentially and is going to continue to expand because of the demand for compute, etc., in relation to AI. And we really need to think about materials and embodied impact of equipment, most of which is designed in a linear fashion. In other words, we take resources, we make stuff, we use it, and we don't think about what's going to happen to it at end of life. And it's a very, very big problem with electrical and electronic products. And in fact, waste electrical and electronic equipment is the fastest growing waste stream in the world. And the data center industry is contributing to that. So we've all become, I would say, I guess, addicted to use of digital technology, which of course the data center industry supports. But we really need to think about the embodied impacts of all the equipment in the industry that enables us to access digital information and communication, etc., whenever we want. So for the past few years, I've been I was the founder and leader of a project called Zodasi, which is kickstarting a circular economy for the data center industry. So instead of designing products that are just where we take, make, use and dispose of them, we actually think at the design stage about what is going to happen to products at end of life. How can we change the design of products so that they can be easily and economically disassembled and materials and components can be separated to increase recycling rates? How can we also extend product life? Because an awful lot of equipment in the data center industry is taken out of service when it still functions very, very well. So we're looking at all of life in the project, taking a whole systems and whole life approach to the challenge of data center sustainability. So we're looking at the beginning of life, the design phase, middle life, if you like, product life extension, and then what happens to stuff at end of life? How can we improve recycling and reclamation of materials? And as I already said, the sector is expanding rapidly. And in fact, I've read that in order to accommodate the compute required for AI, the sector is going to have to expand provision by, it's going to have to treble basically by 2030. So the need to design better, more circular equipment, i.e. equipment that can be easily disassembled, recycled, etc., or repaired and reused. We need to do all of that to ensure that the data center industry can function as we want it to function.
Can you get us up to speed on the, I mean, I know you're not just involved in academic research, you are actually also connected with the industry. And that, you have quite a complete, wholesome picture of what's going on. So if you connect the dots in an integrated way, can you get us up to speed with the latest thinking, integrating research with your expertise inside the tech and the data center business to accelerate the circular economy and incorporate environmental best practice in design thinking? Where are we at here? Can you give us a situation analysis?
Okay, so I think in some respects there is a bit of a gap between academia and the industry, and I see part of my role is to find ways to help industry to appreciate the scale of the problem that it's facing, and to present empirical evidence to show the scale of the problem, but also empirical evidence to show how a change in business practice, etc., can actually improve company profiles. Now, one of the big challenges is, of course, that companies are focusing on carbon reduction mainly in relation to operational energy, which is really important. But to date, there haven't been any tools or any way of demonstrating the embodied impact of products and so forth associated with this sector. So through the SIDASI project, we've collected a huge amount of primary source data and built a tool, the Circular Data Center Compass. And that was developed specifically to help industry and stakeholders to make really informed decisions about the equipment that they buy, what they do when equipment appears to be reaching in industry's perception end of life. Can it be updated? What are the advantages of refurbishing and so forth? So this tool was developed specifically in conjunction with representatives from the industry. The SIDASI project was funded by Interreg Northwest Europe, and one of the remits of that funding stream is to work with industry directly. So we are basically, as an academic institution, offering the industry services that they wouldn't necessarily have access to. So our project started by talking to representatives from all the different industry subsectors, because I'm sure many people are aware that the data center industry is comprised, well, we worked out there were 14 subsectors, but people, experts, phenomenal levels of expertise, but people working in silos, and they don't talk to people in the other subsectors. So they're doing the best that they can within their sphere, but without really understanding the impacts that their decisions have on other aspects of industry. So we started by bringing together representatives from the various subsectors across the industry, and we ran co-creation workshops, which are talking shops in a way, but guided discussions to really identify what representatives of the industry wanted in terms of a tool. What would they, what sort of answers would they like the tools to provide? So right the way through the project, the conversation continued. So we had the initial co-creation workshops, then we developed the tool, and I mentioned before, it's all based on primary source data, which is very different to most other tools, which are based on secondary source data and assumptions. So we believe that our data sets are much more robust. But then again, going back to industry, we organised meetings so that they could test preliminary versions of the tool and give us feedback. So it was very much a sort of co-creative an evolutionary process until we launched the tool a few months ago.
Right. So looking forward, is 2024 a year where business will invest and experiment with decarbonization solutions?
Well, this is the million-dollar question, I guess. I would like to think so. From our experience working with and meeting representatives of the sector, they tend to fall into two camps. People who get what we're trying to do and open to learning about possibilities for change and so forth, and people who really reject the idea without really understanding what's going on. So, for instance, when we give talks at industry events, and I'm regularly presented at Data Center Dynamics, Data Center World, Open Compute Foundation, and last summer I had the fantastic opportunity to go to Antibes for the Platform Markets event, talk to people in industry.
We have grown to be wasteful consumers as individuals, as enterprise, and as industry. It seems a big behavior change or a shift needs to happen towards the practice of recycling and accepting that recycled products are fit for purpose. Why should levels seek care, and where should they start?
Well, this is behavior is part of the challenge, but also having an adequate infrastructure to take equipment and recycle it properly is an even bigger challenge, or at least equivalent to behavior change. So it's very easy for somebody sitting in industry to say, right, I'm going to, tick my boxes, my CSR boxes, etc., and also to conform to legislation, and a recycling company will come and collect my equipment and take it away and deal with it. So, and that does happen a lot in data centers, but unfortunately, quite a lot of the recycling companies are, well, some of them, I would guess, are doing the best that they can, but that's not enough. So at the moment, the main materials that are recycled from equipment, anything with iron in, steel-based materials, copper, aluminium, and gold, and that's it. And in circuit boards, printed circuit boards, for example, there are up to 12 critical raw materials, which if we don't have those, we don't have a data center industry or any digital communication. And they're called critical raw materials because of the amount that is left in the earth that hasn't yet been mined, the recycling rate, which currently is less than 1%, which is a bit shocking, the ability to substitute materials, but also, and this is really important, the location where the reserves are found, and a lot are in geopolitically sensitive areas. So those four factors together mean that these critical materials, which are of high economic and technical significance, most of them are being wasted. They're dumped in landfill and so forth at end of life. Now, so we need to kind of push and pull from both ends of the data center industry. It's fine for the stakeholders to say, we're doing our bit. We get recycling companies to come and take our kit away. But at the moment, there isn't the incentive to build adequate recycling facilities to process all the equipment that is, ready for recycling, etc. And in addition to the scale, we also need to develop facilities that can recycle and reclaim many more materials than are currently recycled.
So how can we reduce dependence on raw materials in favor of recycled materials? And do you see a new market for second life equipment in data centers, similar to the aviation industry and textile industries, where recycle and reuse have grown into an industry in and of themselves? Is there a geographic area or company or a country that is advanced in that way from their policy perspective or from best practice perspective?
Yeah. From policy perspective, in terms of, well, we call it second life or extending product life, because as you know, so many pieces of equipment are taken out of service and replaced with new simply because they've got more, tiny bit more compute capability when actually they function very well. So the secondary market is slowly developing. There are quite a number of practitioners or companies involved in promoting that, be it sort of basic cosmetic refurbishment or more serious technical upgrades and so forth in various parts of Europe. And there is a non-profit organisation called Free ICT Europe, for example, who are campaigning and pushing for better support for that secondary market. Because at the moment there are issues around, for example, warranty, etc. So there's a real drive. There's very definitely in certain sectors, I don't think, although the OEMs aren't terribly happy about it, but there's a real drive to increase that market share, because not only can it save purchasers money, but it also has a very significant environmental benefit, of course, because you're keeping materials in use for longer. You're not mining raw materials.
If we were to approach the circularity issue from a supply security perspective,
that's a really good point. I think that if you think about energy efficiency, that was driven by legislation. There hasn't been any legislation so far related to physical resource efficiency. So, there's only goodwill rather than, as a carrot rather than a stick to kind of encourage that. But I would say that having been to Antibes, to the markets event, that there's masses of opportunity and really fantastic investment opportunities for maybe data center companies to think more holistically, not just about building sites, running them, and then somebody else deals with all the waste, blah, blah, blah. But actually thinking, well, maybe we should start thinking about investing in recycling capabilities in Europe and extending. There are a few recycling plants, but they're very limited. And like developing that, it could be a great business opportunity. And maybe you could actually have circular businesses, where the good thing about having localized recycling and so forth would mean that the materials there's less possibility of materials being contaminated, which means that when they go through the recycling process, hopefully they'll be purer and then much, much easier to use for, manufacturing new products. The great thing about metals is that when you recycle them, in theory, you could do it ad infinitum. They're really stable. Plastics are a completely different kettle of fish. They are synthetic. They were designed, developed for very specific functions, and they perform, that first life function brilliantly. They don't decay, of course. We know we've got a big problem with plastic waste. But when we recycle them, they lose a lot of the inherent properties that they had when they were first manufactured. So you can't necessarily use them for the same product again. You might be able to use it for a lower grade product. But metals, and there are a lot in service in particular, they have the highest environmental impact of all data center equipment, partly because of the materials that are used to build them, but also because of their comparatively short life. So, there's lots and lots of potential to make a kind of whole product life or equipment life system. It just needs more creative thinking and people who, we hear about people working in the City of London or Frankfurt or wherever who take risks, calculated risks all the time. I would think that actually building really good recycling capability for electrical and electronic equipment, the risk is pretty low because the demand for the materials is going to increase. It's time to quote Greta Thunberg and say, blah, 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 no more blah, blah, blah. Let's have some doing.
Are sustainability pledges sustainable in 2024?
As long as the pledge is turned from intention into action and reality, then yes, it's important. And let's I'm full of admiration for the people who stick their necks out and take risks in terms of sustainability. That they're trailblazers. They show by example. And I think it's time for more people to take risks in the data center sector. It makes a lot of money, it uses a lot of resources, and I think that the sort of responsibility, environmental, social responsibility, you know, there has to be a trade-off for the economic gain there. So.
Professor, it's been an absolute honor to meet you today. Thank you very much.
Well, thank you for taking the time to interview me.
Thank you for our audience to follow up on our circular economy. This was Lino Tagliara, Let's Talk Tech.
And Deborah Andrews. Thank you very much for listening. Thank you.